Hi folks, we're going to be looking at the Unit 5 Extra Review number 2. Okay, so I'm going to sketch one of these functions, but I'm going to use this as an opportunity to review function notation versus writing a function explicitly. Okay, so I'll start with B here. This is what I mean by writing a function explicitly. This is the actual function that we're going to be graphing, but we're going to do that by comparing it to a parent function. So since I see an x in the denominator, I know that the parent function I'll be comparing it to will be 1 over x. Okay, then from there I'd have to identify what the transformations are. So this 2 in the numerator would be gotten by multiplying 1 over x by 2. And then here, because I've got an x plus 1 in the denominator instead of just x, okay, that represents my horizontal translation. And then the plus 2 on the outside represents my vertical translation. Okay, say I wanted to write it in function notation. The way we do that is we start by identifying and giving a name to the parent function. So I'll say let f of x be equal to 1 over x, and then I use this to describe how I'm transforming this function. Okay, so as we said, the first thing we're doing is we're multiplying by 2. So it'd be 2 times the function. Okay, but instead of the input being x, the input is x plus 1. So in my bracket here, I'm going to have x plus 1. And then to all that, I'm adding 2. Okay, so this would be how to write this original function in function notation. Okay, so it uses the fact that f has been identified as the reciprocal function 1 over x, and this expresses the transformations on that function. Okay, here it's backwards. It's given to you in function notation. It tells you what the parent function is, so you don't have to determine it yourself, and then you look at these numbers to identify what the transformations are. Let's say I did want to write it explicitly. Let's just do that, okay, as practice. So here, first thing I'm doing is I'm multiplying my function by -3. Okay, and here my function is x squared, but I see that the input is not x, but x plus 4. So I'm going to be squaring x plus 4. Okay, and then to all that, I'm subtracting 1. Okay, so from this example given in function notation, I've written it out explicitly. So this is the actual function we're going to be sketching. Okay, so you should be able to work with either notation. So here it asks us to show how 3 points are transformed. So I'll do this question here. So it means I start with my 3 points on my parent function that we've chosen as our representatives. So 0, 0, 1, 1, negative 1, 1. And now we see how they change based on these transformations. Okay, so I'll do all the x values first. Okay, so I look at my horizontal transformations, and the only thing I have is a translation 4 units to the left. Remember, always opposite for horizontal ones. So 0 minus 4, negative 4, 1 minus 4, negative 3, negative 1 minus 4, negative 5. Okay, now let's see what happens to the y values. I've got 2 operations on the y values. So first I multiply the y value by negative 3 and then subtract 1. So negative 3 times 0 minus 1. Okay, here negative 3 times y equals 1 minus 1. Okay, and then here again negative 3 times 1 minus 1. Okay, so now we can do that calculation. So we've got negative 4, and here this is 0 minus 1, negative 1. Here we've got negative 3 minus 1, negative 4. Okay, and then here we've got negative 3 minus 1, negative 4. So negative 5, negative 4. Okay, now that we've got our transform points, we can more easily choose where to put our axes. So I see that my x values are all negative, so I'm going to put my y-axis further to the right. Okay, and I look at my y values, and again they're all negative, so I'm going to put my x-axis a little higher. Okay, since the numbers are small, I'm going to go up by 1 unit every time. Okay, And now we'll start plotting our points. So negative 4, negative 1. 1, 2, 3, 4, negative 1. Okay, so this is going to be our maximum or minimum point. Now because we see a reflection in the x-axis, we should know that this is going to be a maximum point. Okay, so here, 1, 2, 3. Oh, sorry, I just realized. Sorry about that. This should have been negative 3 here. Okay, so hopefully you noticed that, but let's go back here. That didn't change, so that should be negative 3. So negative 1, 2, 3, then negative 1, 2, 3, 4. Okay, so you should always have your eyes open. Okay, if something doesn't make sense, go back and review what you've done. Okay, because there's no way that there could have been two values of x that had different values of y. Okay, so here, negative 5 and negative 4, 1, 2, 3, 4, 5, 1, 2, 3, 4. And so now we have enough information to draw our parabola. Don't forget to put your arrows to show that it continues to go down towards the left and towards the right. Okay, now this is not too surprising. Again, it opens downward, which we would expect since there's a reflection in the x-axis. Okay, and it does seem to be thinner than y equals x, which is not surprising because of our vertical expansion. Okay, and it's moved 4 units left, 1 unit down. Okay, now the other thing that they've asked us here is to find the domain and range, so let's do that. So the domain, we see that, well, any x value can be input because this keeps going down. Eventually you can pick any x value, so this will just be x can be any real number. The range, though, will not be any real number because we see that anything above negative 1 is not going to be a range value. So here we have y can be any real number, but now with a condition such that y is less than or equal to 1. Okay, so just a quick recap. Remember that you should be able to identify the parent function and the transformations, whether the function is given explicitly or whether it's given in function notation. Okay, that's it.